Okay guys, so I'm going to make you a quick video over section 7.2, applications of the normal distribution. And yesterday, I pretty much started butchering that last night, and so we went on home. And shout out to Misty and Kimberly who were right. I just needed some sleep. When I got up about 4:30 this morning, I sat down and worked through these problems in about 10 minutes. So this shouldn't take too long. So on our applications of the normal distribution, whoops, sorry guys. Let's see if I can, for 7.2, applications of the normal distribution, I do have let x be a value from a normal distribution with mean mu and standard deviation of sigma. We can convert x to a z-score by using a method known as standardization. To standardize a value, subtract the mean and divide by the standard deviation. This produces the z-score. So I've got this formula is important. We did kind of talk about that last night. And the first few problems are pretty simple, and we got through that. The next few, when we kind of hit a roadblock on 4 through 7, or I did, they're actually very simple. We use normal CDF as we did in section 7.1. It's just now the mean and standard deviation have changed. So let's start off with number 1. It says a normal distribution has mean of 15. So I've got my mean equals 15. I've got a standard deviation of 4. And it wants me to find and interpret the z-score for x equals 11. So I'm simply going to say z equals x minus mu over sigma. And I'm just using the formula that we have up here at the top, okay? I'm going to plug those in. I do have x equals 11. Let me circle that there. So I've got 11 minus 15 over 4 is going to give me negative 4 over 4, which gives me a z-score of negative 1. Okay, so that means that the value of 11 is 1 standard deviation below the mean. The value of 11 is 1 standard deviation, I'm going to abbreviate that, below the mean. Okay. If I look at number 2, it says a normal distribution has a mean of 60 and standard deviation of 20. We want to find and interpret the z-score for x equals 75. Okay, so I've got z equals x minus mu over sigma. That's going to give me 75 minus 60 all over 20. I did remember that I do have a TI-84 app on here. So I can go over here and I can say 75 minus 60 divided by 20 is going to give me 0.75. Okay, so a value, or the value, if we keep with the same way as what we were doing in number 1, the value of 75 is 0.75 standard deviations above the mean. So it's not quite 1 full standard deviation above the mean. Okay. Number 3, compact fluorescent bulbs are more energy efficient than incandescent bulbs, but they take longer to reach full brightness. The time that it takes for a compact fluorescent bulb to reach full brightness is normally distributed with a mean of 29.8 seconds. Okay, and a standard deviation of 4.5 seconds. A randomly selected bulb takes 28 seconds to reach full brightness, so that's my x. Okay, we want to find and interpret the z-score for x equals 28. So I've got z equals x minus mu over sigma. That's going to equal 28 minus 29.8 all over 4.5. So I'm going to go over here to my calculator, and I'm going to say 28 minus 29.8 divided by 4.5, and that gives me negative 0.4. Okay, so let's see. I need to box these. The value of 28 is 0.4 standard deviations below the mean. Notice I did not say a negative 0.4. I used below to represent that negative because this is below the mean because our value is 28 and the mean is actually 29.8. Okay. All right, number 4. Okay. So let me erase this. This was from last night. And I'm going to go ahead and I'm going to erase these because I'm going to reteach all these also. Okay, so on number 4, I have a normal population has a mean of 3. So mu equals 3. A standard deviation of 1. Okay, so sigma is 1. Find the proportion of the population that is less than 1. Okay, so what we have is we want less than 1. So we're going to use, here's what we're going to use here. We're going to use our normal CDF because we're looking for the area. And if you'll remember back in 7.1, what would they do? In 7.1, when we were looking for, I could pull that back up. On example 3, it says find the area to the left of z equals 1.26. Okay, so we're looking for the area. If I'm looking for, and we're also looking for the area here. When it says find the proportion, find the probability, find the proportion, find the probability. Guys, this means that we're looking for the area of these things. Okay. Now, they've not necessarily given me they have given me a z-score here, but it's saying it's less than 1, so it's not going to, it doesn't look the same as in our normal CDF is the problem. Because when we were working in normal CDF, what did we do? We used a mean of 0 and we used a standard deviation of 1. Here the mean is 3 and the standard deviation is 1. Okay? So when we go to calculate the normal CDF, it's going to look a little differently, okay? When it says this is less than 1, I'm coming from the negative up to 1. So that means that my upper there equals 1. My lower is going to be that negative 1e to the 99. Remember how we would do? Okay, so I should have normal CDF negative 1e to the 99, comma 1, because that's my upper. But then remember, this time we're changing it. The mean isn't 0 anymore. The mean is 3, and that standard deviation, yes, it's still 1 in this particular problem. So I go over here. I'm going to clear this. I'm going to do second vars. I'm going to go down to normal CDF. I'm going to hit enter. Okay. Now, this one doesn't do, this one does more like my emulator here, does more like what Misty's TI-83 does, okay? So it does tell me here that I want the lower, so that's -1, and I use second, comma, that gives me my E. It should have. Let me delete that and make sure, whoops, -1. I don't like it's using second. Now let me try, comma. It still did it. Let's see if it works right. There it goes, comma, 1. So my lower limit is -1 e to the 99. My upper is 1. I got that from the problem. Then now it wants my mu, or my mean. The mean here is 3. And then it wants my standard deviation, which in this particular case is 1. Okay? We hit enter and we get 0.0228. So that gives me 0.0228. Because remember, guys, when we drew that curve back over in, it was over in 7-1. Let me see if that one is still here. Okay, so this was giving me the proportion or the percent, but that was also giving me the area. Remember, 0.68, 0.32. We had things like that. Those on my inverse norm over here, they specifically would tell us my lower and upper with my z-scores, okay? We would, right here, notice on example 3, it says find the area to the left of z equals 1.26. They're telling me that the value is 1 here, okay? But that's still the area. That's the proportion. Okay, let's practice another one. All right. So we've got a normal population, has a mean of 40. We've got a standard deviation of 10. We want to find the probability, which is the area that a randomly sampled value is greater than 53. So that means if I'm going greater than 53, that's my lower limit. My lower is 53. My upper is going to be all the way to positive 1e to the 99. So for my normal CDF, I should have 53 is my lower, 1e99 is my upper. Okay, then I have my mean, which is 40 here, and then I have my standard deviation, which is 10. Okay, so I go over to my calculator and I'm doing second vars 2 again, and I'm going to put in, this time we said that 53 was my lower. I've got 1 second E, 99 is my upper. Then I've got 40 as my mean, and then I have 10 as my standard deviation. Okay, and I get 0.0968. Okay. All right. Number 6 says a normal population has a mean of 7, so mu equals 7, and standard deviation of 5. Sigma is 5. Find the proportion of the population that is between -2 and 10. So my lower is -2. My upper is 10. Okay. So we're going to go ahead and find this, and then we're going to kind of look at a picture. You know, I like to give y'all a graph of what this is really talking about, and I need to do that. So if I start with my lower, so that's -2. I'm going from -2 to a +10. Then I'm going to need my mean, which is 7, and then my standard deviation, which is 5. So I'm going to go to second bars, number 2, my normal CDF, and I have -2 as my lower. I have 10 as my upper. I have 7 as my mean. And I have 5 as my standard deviation. Okay, I hit enter, and that does give me 0.6898, about 69% of my population there. So I'm going to write my answer right here. And let's look at kind of a little picture of what's going on here. Okay, so guys, what you have is you have your curve here, and mu is no longer 0. Like when we were looking at the standard normal curve in 7.1, we set mu to be 0, and then there would be 1 and -1. That was 1 standard deviation away. 2 and -2 were 2 standard deviations away. 3 and -3 were 3 standard deviations away. But here, these are applied. This is why it's applications of the normal distribution. Okay, so this one says we have a mean of 7. And so here's 7. Then it says, and a standard deviation of 5. So that means 1 standard deviation away would put me at 5 above 7. So that's 12. And then 5 below 7 is 2. Okay, that's 1 standard deviation away on both sides. If I went 2 standard deviations away, so that's going to put me at 17, and then 7 minus 10 is now at a -3. Those are 2 standard deviations away. Here's my mean, and I'm going to kind of write in this other problem. This is 1 standard deviation, 2 standard deviations. That's still 1 standard deviation, even though it's the negative. There's 2 standard deviations. And what this question is asking me is, okay, what percent of that population falls between -2, so right here, and a +10, which is about right here. Okay, so guys, it follows a normal distribution curve. And if we look back at 7.1, and we go over here, I think it was on the first page. Maybe it was the second page. Second page, okay? 1 standard deviation away is 68% of that population, or 0.68. That's the proportion. So if I switch back here, I'm not quite up to 1, but I'm a little past the 1 over here. So it's going to be around 68% or more that's occurring. Okay, because in a normal distribution curve, that 1 away, because it goes by the empirical rule, that 1 standard deviation away is about 68%. Okay, well, we're nearly up to 1 standard at the 10 with the 12. We are a little past the 2 over here when we're looking at the lower is -2. But so you know it's going to be at least 68%, and it's nearly 69%. Okay. We can go back and look at pictures of this one also, like number 4. If I go back, and I should have given you a picture on that one to start with too and kind of explain it, and I apologize for that. So our mean here is at 3, okay, and our standard deviation is 1. So 1 standard deviation away would be at 4 and at 2. This is asking me find the proportion or the area or the probability of the population that is less than 1. Well, I got to keep going. Now I'm 2 standard deviations away. That puts me at 5, and that puts me at 1. So I'm looking for this right here, it's not necessarily one standard deviation. It's not a z-score of 1. It's the value is 1. And guys, 1 actually sits at z equals -2 because it's 2 standard deviations below. Okay, this 1 is really at z equals -2. If I did it based on 0 and with 0 being the mean and 1 being the standard deviation, okay? But you're wanting this less than 1 part right here. Guys, that's over 2 standard deviations away. We know from our picture down here that at 2 standard deviations away, that's 95% of the population. Well, it's actually above that. 2 standards above is is about 2.5 plus the 95, so 97.5. So you're looking at less than 3% of the population that's less than 2 standards to the left over there, okay? And that's what you're getting. You're getting 0.022, so that's 2%. All right. If we look at 5 picture-wise, and I'm going to, oops, I deleted way too much of that. Let me make that eraser smaller. Okay. So on this one, it says my mean is 40. Okay, and 1 standard deviation is worth 10. Well, at 1 standard deviation above, I'm at 50. At 1 standard deviation below, I'm at 30. Okay, now what does this say? This says find the probability that a randomly sampled value is greater than 53. So it's greater than, we're looking, here's 53 about right here. Okay, it's greater than 53. Well, guys, 50 is 1 standard deviation away. Okay, so you've done your, if we go back over here and look at our picture, well, mu is 50%. This 68% means there's 34 on this side, and there's 34 on this side. So right now, you've taken care of 1 standard deviation away is already over 84% of the population, right? Okay, and we're at 53. We're on past that, okay? And we just want that little bitty chunk. Well, the max it could be is about 15 because that's all that's left if we were sitting at 50. That's on that end down there. And we're even down past the 50. So it should be less than 10%. Definitely less than 15%. And of course, what'd you get? You got pretty much 9.7%. Okay, which is correct. Okay, if I look at numbers, we did number 6, the graph on number 6. So let's look at now number 7. A normal population has a mean of 56. So here's my graph. Here's my mean of 56. Okay, and standard deviation of 12. Well, 1 standard deviation above and below, 1 above is going to be 68. Okay, 1 below should be what? 44? Because 44 and 12 does give me 56. Okay, it says find the probability that a randomly sampled value is between 60 and 70. Okay, well, let's look at what 2 standards above are going to be. So if I add 12 to 68, that gives me 80. Okay. We want between 60. So we're talking from about right here to 70. About right here. Okay. So if we go, well, my average is 56. My standard deviation is 12. Okay, my lower is 60. My upper is 70. So I've got normal, CDF is going to be, lower is 60, upper is 70. My average is 56, and my standard deviation is 12. Okay, so I go over here to my calculator, and I do second VARS, number 2, normal CDF, and I'm going to put lower is 60, upper, sorry guys, lower is 60, upper is 70, mean is 56, standard deviation is 12, okay, and that's going to give me about 25%, okay, and I'm getting 0.24, was it 78 or 97, what was it, sorry guys, 2.477, so 2.478, okay. Okay, not too bad. So that was all 4 and 7 were, is you're using a normal CDF function, but we no longer have a mean of 0 and a standard deviation of 1. It changes depending on the problem. Okay, but you're still doing the same thing. You're finding the area, you're finding the probability, you're finding the proportion. Okay, they don't necessarily give you a z-score of 1, z-score of 2, like they did in 7.1, because you don't necessarily know the z-score that goes with this. You could calculate that z-score and then plug that back into the normal CDF and use 0 and 1 if you wanted to, because we could get a z-score based off the x minus mu divided by the standard deviation. So we could have done more with this problem, done more math, if we had used z equals x minus mu over sigma, because I could gone, okay, populate, we would have gotten the z-score, and then we would have to put it in the normal CDF. So let's do, since that standard deviation is 1 there, that's a little confusing on that one with the value being 1. So let's look at 5 and use this on 5. Now, like I said, you can just simply use normal CDF. You can change that mu, you can change that sigma, and you're going to get the right answer. These were designed to use a table with, so you would have to get a z-score first. I'm not going to make you use a table on a test. I'm not going to make you use a table on final exam, okay? So if you can use your calculator, we've given you one. So if I was to convert to a z-score first, like on number 5, I would have z equals, I know that x is what you would have to get, it's greater than 3. So z is 50, x is 53 minus 40 divided by 10. That would give me 13 divided by 10, which is 1.3. It's a z-score of 1.3. Guys, look, 50 was at 1 standard deviation, and we're a little past that. Sure enough, that's a z-score of 1.3. So if you put this in your normal CDF and you are using the typical normal distribution with the 0 and 1 there, we would put, we're going from a z-score of 1.3 to 1E99, comma, then our mean is 0, our standard deviation is 1. Let's see if we get the same thing. Let me write this down over here. I've got 1.3, 1E99, and I've got 0, and I've got 1. So I go over here back to my calculator. If I do second VARS 2, and this time I'm going to treat it like we were before, 1.3 to 1 second E99, comma 0, comma 1. If I put that in the right order, yes, I did. And that gives me the same value that I got with the 0.0968. So the deal with these problems were, okay, if you're not using technology on them, you have to convert and find the z-score first, and then you were supposed to go to the table and read it off the table. If your calculator didn't have the ability to change that mu, to change that mean, which is mu, or that sigma, that standard deviation, to what you needed, you would have to calculate those z-scores first, so then you could use 0 and 1, okay? But there's the gist of 1 through 7 that I somehow could not teach you last night. We started muddling through 8 through 9. I'm not really sure how much of that we got through, so I went through there and I did something nicer for you when I worked them this time around. Okay, you need the formula if up there if you are going to find that z-score, or you're going to find that x, because you're looking for the z-score and you need to convert it. But honestly, your calculator, you don't need to convert it. You're not using a table. The formula that we have, of course, is x equals mu plus sigma times z. I did show you where this came from. We had how to calculate a z-score as x minus mu over sigma. Then when I solve for x, I've got to multiply both sides times sigma. That's going to give me sigma times z equals x minus mu. Then I'm going to add mu to both sides. And then that will leave me with mu plus sigma times z equals x. And that's where we get that formula for x, okay? Now, like I said, since you have a graphing calculator, you can just change mu and sigma from 0 and 1 into what the standard deviation is and what your mean is, okay? Because your calculator does allow you to do that. So a normally distributed population has a mean of 6.9 and standard deviation of 2.6. Sorry about that. Find the value that has 80% of the population below it. Okay, so that means my area is 80%. Okay, we've shaded in 80%. So we have our, and they're wanting to know the exact value. They're not wanting to know the z-score. Before we would find the z-score, back in 7.1, when we were using inverse norm over here, it would tell us, let me find it, there we go. It would tell us, okay, I have an area of 0.26, the mean is 0, the standard deviation is 1, what's that z-score? Okay, well, you can do that and you can recalculate that with the appropriate mean of 0 and standard deviation of 1, but you don't have to. You can use inverse norm, put your proportion in there, put the new mean in there, put the new standard deviation, and it will give you the value, okay? So, I can go back over here, all right, and my proportion, my area is 80th percentile, so if that proportion, area, whatever you want to call it, 80%, that's really 0.80. So you shaded in 0.8 of that curve is what it's saying. All right, and it's saying it wants to find the value that has 80% of the population below it, okay, or the 80th percentile. Well, here's mu in the middle, and that mu is 6.9. Okay, you know that's at 50%, so it's going to be shaded past that, okay? So we're going to use our inverse norm. Well, guys, here's the deal. If mu is 6.9, then one standard deviation is, what is that? 9.5, okay? One standard deviation above is going to be up to 9.5, okay? That value is. I'm saying we're going to probably see more than that. We're going to see a value higher than that simply because if I go back over here and I'm looking, I told you this was 50% at mu, then this other small chunk, this half chunk right here, that's going to be 34%, okay? And so I've got the 50 plus the 34, that's 84%, goes pretty much up to one standard deviation away. And what was I looking for? 80%. So actually, it's probably going to be a little below 9.5 is what I'm going to predict. Okay, because one standard deviation, all of that added up should be around 84%. So this is going to be, I'm going to predict a little bit less. We're going to get a value a little bit less than 9.5. But let's see what happens. And I may have to cut this chunk out of the video. So I'm going to use inverse norm. Okay, and it appears in the inverse norm. I put my proportion in, 0.8. Then I put my mean in, which is 6.9. And then I put my standard deviation of 2.6. So let's see what happens if I get a value that is a little less than 9.5. So I'm going to go to second bars, and it is number 3 on this particular calculator, my inverse norm. It tells me I want the area, which is 0.8. Then I'm going to need that mean, which is 6.9. And then I'm going to need that standard deviation, which is 2.6. Okay, and that's going to give me 9.08. What did we say, guys? I said it was going to be less than 9.5. Don't have to edit the video. Well, not that part anyways. And I get a value of 9.088. Okay. Number 9 says a normally distributed population has mean of mu equals 53. Okay. And standard deviation equals 34. Find the value that has 35% of the population above it. Okay, so we want 35% above it. So we really need a picture so you can see, because we're not going to enter 35% in there because we're doing the inverse. Okay, so if I'm at 35% above, so let's say it's this chunk right here. How much is below then? If I'm 35% above, remember we got to get 100%. So if I'm 35% above, that means this is 65% below that value, right? So that's really what we need to look for, because like we said, our calculator is not as smart as Robert's. And so we do that tailing to the left. We have to do that ourselves. We can't tell it itself. Robert, you should be able to put the 35 in and tell it to tail to the right, and it should give you the correct value. Okay. So in this particular one, my proportion is really going to be set for my input into my calculator. My proportion is really going to be set at 65%. Okay, well, once again, there's my 50%, and that's at 53. My standard deviation, one standard deviation is at 34, and that makes up, so we're going to get a value less than 87 for sure. I would say it's going to be a value greater than 53 and less than 87. Most definitely, but we're going to try it. Here we go. So, and that of course is 0.65. I'm going to say inverse norm is going to equal, I've got 0.65. My mean was 53. and my standard deviation was 34. So that's going to give me, I'm going to go over here to my calculator. We're going to do second bars again. Number 3, inverse norm. That area we said is actually 0.65 because our calculator is due to the left. Then I need a 53 was my mean, and then my standard deviation was 34, and it gives me a value of 66.10. And I believe I told you it would be between 53 and 87 for sure, and sure enough, we got 66.10. Of course, I did give myself a good size window on that one. So let's look at number 10. A normally distributed population has a mean of 27, okay, and standard deviation of 12. Find the values that separate the middle 60% of the population from the top and bottom 20%. So here's what we're looking at, guys, and you really need a picture on this one. So here's my 27. That's my average. That's my middle, and it wants 60%. It wants to know what two numbers right here are going to make this 60%. Now, they are nice, and they tell you this is 20 right here. Now, this one's not going to work out as nicely as our inverse norms from 7.1, because 7.1, our mean was at 0, our standard deviation was 1. Okay, so we'd have a 0, we'd have a -1 and a 1. We'd have a -2 and a 2. So what that meant was if we found this left right here, then we could, and it would be negative, then we could just make it positive over on the right. That's not going to work here, guys. Okay? So what we have to do is we're going to actually have to find two different values to start with. Okay? You can't do the plus or minus there, guys. Okay, so the first thing that we're going to do is we're going to find this first one right here. I know that's 20% to the left, right? It even told me it was 20% to the left. So I'm going to find for a proportion of 0.20. So I'm going to say inverse norm. I'm going to say 0.20. I'm going to say 27 and 12. Okay. So I'm going to go here. Second, vars 3 is my inverse norm. I've got 0.20. I've got an average of 27. And then I have a standard deviation of 12. Okay, 16.9. So what that tells me is this value right here, this little value right here, is actually 16.9. You have one of them. You have one of your bounds, 16.90. Okay, that shows, that starts where we can start counting that middle 60%. Now I've got to find this value. We're going to color him green. Okay, well, I need to know how much is really to the left of that value so that I can find him. Well, we got the middle chunk at 60, and we got the baby chunk down here at 20. Of course, you also know this is 20% to his right. So that means this total piece down here is 80%. So now I'm going to find the inverse norm with my mean of 27, my standard deviation of 12, and my proportion this time of 0.80 or 80%. That's this whole thing up to this magic point right here. Okay? So I've got inverse norm is 0.80. I've got 27 and I've got 12. Okay, so I go back over to my calculator. I've got second bars, number 3 for my inverse norm. I've got 0.8 because it's 80% of my population. I've got 27, and then I have 12. 27 is my mean, 12 is my standard deviation. That's going to give me 37.10 because it's 0.99. So I'm going to round that up to 37.10. So this value right here is 16.9. And this value right here is 37.10. If we actually redid that the other direction, if we used our normal CDF and we did a lower of 16.9 and upper of 37.10 with the, let me write that down and we'll show it. Okay, so I'm going to do a normal CDF. And I'm going to go, I have a lower limit of 16.9. I have an upper limit of 37.10. And then I'm using an average or mean, of 27 and a standard deviation of 12. So let me go back over here. I'm going to go to second bars. I'm going to go to number 2, normal CDF. My lower limit is 16.9. My upper limit is 37.10. Then I have a mean of 27, and then I have a standard deviation of 12, and that does give me 60% of my population right there. Okay, so we just proved that we were right. Good job, guys. And like I said, that was a much better lesson than what you guys were getting last night. Okay, hope that helps on the 7-2. I may make you a new 7-1. I'll ask if you would like that, and we'll see what happens. I'm not sure how great my 7-1 lecture was last night. Probably not the best, guys. Okay? All right, there's 7-2.